For those of you that don't know, my name is Jason Ippolito. I am a senior mechanical engineer. I am one of the workshop managers of ASME this semester and past semester. Today we are going to do a workshop about how to use 3D printing as well as a CAD program to take your idea on your software of whatever computer or whatever software you're using and transform it into a physical object. Now, as you know, a lot of industries use 3D printers to sort of, make a high-res prototype of something. Well, in this case, we're just using it to make our actual product, which is going to be this little holder that can sit on your desk and hold, a couple pencils in it. And the way we're also making it, it can also pivot on this bottom circle you see right here. So if you have Solidworks installed, you can open up Solidworks and follow along in that. If not, that's okay. You can use Onshape, which is free. It's right in your browser. You don't need to download anything. You just need to make a profile or make an account, log in, and you're able to find this. Now, if you are using Onshape, you're actually able to simply search up this part file. And if you're using Onshape, you would open up Onshape, it would take you to this general area. This is sort of all the files that you've created. If you look on the left, you'll see it says public. And from there, you can see all the stuff that other people have made. And you can even search up for my part file, and you can copy it. So in case you wanted to use it as reference, or if you simply would like to skip to the last step and just have this, if you don't feel like actually making the part, you can just simply go ahead and download this. Or if you just want to take my part file and tweak it a little bit, that's okay too. But how you would do that is you go to the left, you go to public, and up top, you type in whatever I named it, which is Rowan pencil holder. With the little magnifying glass, give it a second, and the top result should be the file that I created, and you should be able to open it. Yep, there it is right there. You're able to open it up, make your own version of it. And like I said before, whatever you're using, SolidWorks, probably Autodesk or Onshape, you can make the same thing. See here, you see the part that I made in Onshape, excuse me, and the part that I made right before it in SolidWorks. It's the same part. Some of the nomenclature is different, but otherwise it's the exact same part. And as I was saying before, we are going to make this on a little bit of a swivel. So if I do a section view, we have a cross-sectional view. We can see right down here, we made a little gap between this bottom plate and this top holder, and we have this little swivel on the inside. So this top part is going to be able to rotate around it. So I'm just going to open this up in Onshape, and I'll use the rollback bar to show you step by step how to do this. So when you start off, you're just going to have, your three planes, top, front, right, and they're all going to be visible like this. But we're going to start off by actually making, sorry, I got to scroll around. Got to get used to the controls again. We're going to start off by making a couple other reference planes to sketch on. Now, the way CAD programs work is you take a plane and you create a sketch. A sketch is a 2D drawing, and you're able to take that sketch and turn it into a 3D shape in a couple different ways. So if you were to take, a rectangle, you can extrude it, which means it pulls it in the normal direction. So if I were to sketch on this front plane, and I can extrude it, in the direction that's normal to this plane, make it into a 3D shape. Or I could revolve it, meaning I rotate it around some axis to create a circular shape. Or what we're going to be doing later is lofting, which is taking two different, 2D shapes and filling in the space in between. So to get started, we actually want to make a new plane. And the way you do that on Onshape is go in this button right up here, click this drop down in case that's not there, and you want to click plane. And when you go to make this plane, you want it to be offset by 3.5 inches from the top plane. If I'm going too slow, or I'm sorry, if I'm going too fast at any point, just let me know. I can go back over something. I want everyone to be on the same page. Casey, were you the one asking about which CAD program, or asking about Onshape?
Yeah, I just made an account, so I'm in.
Okay, so like you're able to get into the part creator?
Yeah.
Okay, good. See, we have this first plane. Here, let me change some of the visibility. So right now I just have the top plane showing. And here is plane 1. It is 3.5 inches away from the top plane. It's parallel to it. And then after we do that, we're going to make a second plane. We're going to be using these to make sketches on them later. As you can see, this second plane, plane 2, was at a bit of an angle. That's because we use this midpoint, or I'm sorry, midplane relation. So if I go and look at plane 2, you see I clicked both the front plane and plane 1. And instead of offset, I clicked on midplane, which sort of makes it, you know, intersect between the two planes at a 45-degree angle, or whatever the midpoint angle is. That's our plane 2. So now we're going to start making some sketches. So the first sketch is going to be on this top plane down here. Now you can click on the sketch to highlight, or I'm sorry, you can click on the plane to highlight it, and you can go up to click sketch, or you can just right click the plane and click new sketch. And it'll take you into here. Oh, give me 1 second. I'm just going to hide these to make it easier to see. And what you're going to do is you're going to want to make this sketch. So you have this little dot in the center, that's your origin. And you want to make a circle first. But we don't want to actually use this circle as part of our sketch. We just want it to be there as a reference. See how it's a dotted line? That means it's construction geometry. The way you do that is, first you want to make a circle, and we want the origin to be right here. So we're going to click and drag out and click again. Now we have this solid blue line. So because it's solid, that means it's actual geometry, meaning it's part of the sketch. It's not there for just reference. And because it's blue instead of black means it's underdefined. This black line right here means it's fully defined and there's no way I can change it. If I click and drag, it's not going to do anything. But if I click and drag on this, it changes because I never defined how big the diameter is. First, we would like to make this circle construction geometry. So we're essentially making this. So we're going to click on it, and we are going to go to this right here. See how it's going from blue line to dotted line? That's changing something to construction. If you're in Onshape, alternatively, you could just press Q, and it'll turn it into construction. Now we have a construction circle. And I'm just going to delete this circle because I'm just using it as an example, because I already have this circle right here. I already made this part. Now you want to define that circle. So you want to go up here to this dimension tool, where you can just press D, and you want to click on the circle. It's going to drag out a dimension, and you're going to click again. Here, actually, I'll show you how to do it right now. So now it's blue, so I want to dimension it. Click on it, drag it out, click again. It's going to ask me to enter some sort of value, so I'm just going to make it 1.5 inches, and click enter. Now what we want to do is we want to make this hexagon around it. So you go up here to the line tool and simply draw a hexagon. Click, drag, drag. You don't have to be exact right now. You just want to make a pretty generic hexagon. You want to make sure you connect it at the end. Now we want to make it look like this essentially. So we are going to click and highlight all 6 of these pieces, and we have to use constraints and relations to turn them into a polygon, a hexagon that is fully defined. So one thing we can do to define relations, we can go up here, click this drop down, and first off, we want to make them all equal to each other. That's something that to start off with. Another thing we could do is we could start making sure that these are all parallel to each other. So click 2 opposing ones, click the drop down, go to parallel, and just do that for all 3 pairs. Since I already picked parallel, I can just click this right here. And one more time. So now, it's obviously still blue, and I can still move it around. So we want to fix that. We want to take this circle that we made, and we want to make this hexagon tangent to it on all sides. So you'd click the circle, the line, and click tangent. And now this line is we'll still be able to move it, but it can only move in the X direction. Now it's permanently in this sort of horizontal direction, and it's tangent to the circle, so it's always touching it. So now we're just going to go to this one, do the same thing, Oh, sorry, I forgot to click the circle. So now that one's tangent to the circle, I think. Hold on. Let me redo that one. Onshape is weird sometimes. Sometimes it automatically defines relations for you without you knowing. So you click the line, click the circle, tangent, and you'll just go around and do that for the rest of the lines until you get a nice little hexagon. Right. And then for those of you following in Solidworks, it should be almost exactly the same what you're looking at. Give you a quick view of that. I'm a lot better with SolidWorks, I swear. So in SolidWorks, you should have, the same thing pretty much. It looks a little different, but you have the same thing, dotted circle, 1.5 diameter, in inches, by the way, and you have this hexagon around it, and it's all black, meaning it's all fully defined. And as you can see from this, we're going to be making this. Now going back to this, so there's our first sketch. So now we want to make the second sketch. This second sketch is going to be the exact same thing, but now it's going to be on plane 2. You see, for reference, let me actually, so our first sketch was on the top plane, our second sketch is now on plane 2. So if you were to go to the sketch, it'll be the exact same thing. Now, I'll get to, this little component right here in a second. Let me just, no? Okay. I'm trying to figure out how to be normal to that sketch. Anyway, the reason why I have this defined is because without this line, this would just be free-floating. In SolidWorks, whenever you start a new plane or a new sketch, it automatically defines an origin for you. It would look like 2 red arrows, one going in the X direction, one going in the Y direction, or some perpendicular direction. Meaning, for every sketch, you can just, kind of like what we did for the top plane, you see that dot there? That's like our origin. We constrained our sketch to that dot, meaning it's fixed, because the origin is fixed. But when I started this sketch, I didn't have that option, which is why I made this dotted line to make this new sketch in reference to the origin. And how I did that, because without that, see, now I can just move this around. And how I did that is I made a line, made a construction, and I just went from that center, and I just hovered over that origin and clicked on it. Oh, sometimes that doesn't work though, because it doesn't recognize it, because technically not on the sketch. So you would click the dot, click that origin, go up to the relations, and make it coincident. And now it fixes it, but I didn't define how long it is away from the origin. So this dimension doesn't matter too much, but as you saw from this shape, we want it to be, somewhat above the first sketch. So we're just going to make it, say, 2.25 inches. Now, if we look at it from the side, you see there's the first sketch, there's the second sketch, almost fully vertical above them. It's probably the only part of this whole part that is, a little bit of finagling. You always want to make sure you define your sketches. You want to fully define everything, because if I were to just, leave this out, oops.
Jason,
yeah?
sorry to cut you off. I just had a question.
Yeah, sure.
Yeah, so for the top portion of the pencil holder, did we specify which plane to draw that on? You wanted that on the top plane, or you wanted on that 45-degree plane?
The 45-degree plane. So in my sketch, that's plane 2. That's the one that's going at an angle.
Okay.
Yeah.
I see. And that bottom plane, does that need to be the same size of the same polygon?
Yes, the bottom sketch and the top sketch, they're the exact same thing. So it's that
Okay.
circle that's 1.5 inches in diameter with that hexagon around it.
Okay. Thank you.
Yep, no problem. And if you want, keep the circle the same, but if you guys want to customize your piece a little bit, you can make it an octagon. You can make it a square. Just make sure like all the sides are tangent to each other. However you want to customize it, or if you just want to keep it the same, that's fine too. Yeah, like I was saying earlier, you want to make sure all your sketches are defined, or all fully defined in some way or another, You never want anything to be blue in your sketches when you define them, because it may look like what you want your part to look like as the product, but you may accidentally, slide this over, and it could drastically change what your end product will look like, because you did not fully define it. So, you don't really want to eyeball things. You don't want to just leave it like that and call it a day. You want to constrain it in some way or another. So just to reiterate, same sketch as before, this time on plane 2, which is the 45-degree angle plane. We have a circle, 1.5 inches, and its construction, and we have this hexagon around it. That's all tangent to all sides of the circle. Now, like I was saying before, I'm going to move on if that's all right with everyone. Like I was saying before, you can turn your 2D sketches into 3D objects. So we are going to connect these two hexagons with what is called lofting. So if you're on Onshape, you're going to click this thing right here. If you're on Solidworks, you're going to go to Features and click this right here. It says Lofted Base. Now, I'm going to show you how to do it. This is what your end product is going to look like. So you want to click on Loft. It's going to ask you for the profiles. Click on the bottom one, click on the top one. Doesn't necessarily matter in what order. They should have the same result. But what you want to do is you want to check mark this box Match Vertices, because without it checked, it's going to look like this. Which, if you want to do that, that's perfectly fine. But if you want to add a little bit of a twist to it, quite literally, you click on Match Vertices. And here, let me show you how it's done. Since you want there to be a twist, quite literally, you want the vertice lines to match up differently. Like right now, it's this one going to the one directly above it. But in Onshape, if you want to switch it, you click this one, and then you click the next one, and it'll add a twist to it. Or, you could go the other way. You could make it, I unclick the second vertice, and I click the other one. Now it's twisting the other way. So however you want to do it, or if you just want to keep it, a straight sort of obelisk, that's fine too. Doing this in SolidWorks is, almost the exact same process. You would click on Loft, and you have your profiles from Sketch 1 to Sketch 2, except in SolidWorks, it takes out that extra step of needing to click that check mark box, Match Vertices. You simply do that all in one go. So I would click Sketch 1, I would click that specific dot, and I click this dot up here, Sketch 2, and it automatically adds that twist. So if I didn't do that, if I just click this dot, then it would make that sort of obelisk shape. But if I click that dot, now from that vertex to that vertex, the vertex follows that sort of flex line. Does that make sense for everyone? Again, however you want to customize it, just don't go too crazy, because you do need to 3D print these, and if it's, got huge overhanging parts or some other ridiculous geometry, the print is going to fail. So you want to make it, reasonable. So this is pretty reasonable. If you want to do a square, if you want to, keep it straight and not curvy like this, whatever you want to do. So there's our loft. So let's get working on some other features. So now we're going to work on the bottom. We are going to work on adding out this little, here, actually, let me not show it on the map. we're going to add this little hollow section on the bottom. So I'm just going to click this over here and go to, hold on, let me move the camera windows. I'm going to click on shaded with hidden edges. So now it's just going to show me all the hidden lines. So those are the lines right behind this solid object. So now I can see through it. As you can see, there's that dotted circle down there. That's one of my sketches that I just started. And to do that, to make this sketch 3, you hold the right mouse button and you rotate your part and you click on the bottom face, right click it, and it'll say new sketch. Now I already have a sketch 3 there, which is why it says that, but you would start a new sketch. And it's just going to be, a circle on the bottom, start from this dot, use the circle tool, define it to be 1/2 inch diameter. Right now we're just hollowing out the slot to go on the bottom of this pencil holder so that swivel part can insert into some cavity. And it may not seem like it's appropriate to have like these hidden lines shown to sort of see through the piece, but it will come in handy in a second. So then we're going to take that sketch and we're going to extrude it. Now the extrude command is right here. You just click on it and you go to remove, make sure sketch 3 is selected, and we want to extrude it, or extrude cut it 0.45 inches. Once we do that, now we have this little cavity, and you see if I rotate the part, you can see that hollowed out cylinder section. Just to make this a little easier to see, I'm going to show the front plane and just, see how it sort of slices right through the middle of the part. That's going to come in handy in a second. So right now we're looking at the bottom of the part. We just cut out this cylinder, and we want to sort of add a shape to it right now, because if I go back to SolidWorks for a second and I show you the final product, here's what we actually want it to look like. So if I show you this nice cross section, so we want this cavity filled out, we want this extra little space right here, and then on the bottom swivel part we want to make this little T shape so that it's able to move around, but it's not able to simply slide right out. If you were to pick up the pencil holder, it's not going to just fall off the swivel. So that's what we're trying to make right now. So we already made that first cylinder. Now we are trying to make another part to it. So we're going to make a new sketch. And the reason why I showed the front plane to make this visualization easier is because we're going to start a new sketch on the front plane. And also now, we can see where we are right now. That's why I have the hidden lines shown. So we have a sketch on the front plane, so you can scroll back up, start a sketch on the front plane. And we're just going to make this rectangle. Oh, why is it not? There we go. So we have this rectangle. We have this construction line just as a reference, because we don't want to actually use that in this sketch that we're about to do. And we just have a rectangle, just hanging off of that line right there. That line is right in the middle bottom of the part. That line is 0.45 inches long, and this rectangle extends out 0.4 and is 0.2 in width.
How tall did we want this?
Excuse me? How tall do we want which part? Like the whole thing? It should be already defined because of when we made plane 1 and plane 2. Plane 1, we didn't really make any sketches on plane 1. That was just to sort of offset the height from the top plane. Here, I'll show you both of them. So we started out with the top plane and we made a new plane, which is 3.5 inches away. And then we made plane 2, which is at an angle. So right here is 3.5 inches from the bottom. So at about that point, it's about 3.5 inches tall. So it's, a little more or less depending on which side you look at it. But your object is going to be about that tall, 3.5 inches, because of this first plane that we defined.
Yeah.
Does that answer your question?
Yes, thank you.
Yeah. So normally when you're doing an extrusion, it asks, well, how long do you want to make it? But because we have these planes defined and we were using Loft, we already had the start and end points defined for us. So we simply just connected them. So I'm going to hide those planes for right now because I don't want too much on the screen. I'm going to show the front plane again, and I'm going to go back to sketch 4 in case, any of you finished. We just have this rectangle and this construction line. Don't forget that this is a construction line. That's just a reference. It's coming from the center, from the origin, and it's going up vertically. And then we have a little rectangle hanging off of it, sort of like a flagpole. You use either the line tool to just draw this out, or you could use the rectangle tool. I used corner rectangle just because it's easier. Start up here, click once, click again, there's your rectangle. And then once we have that rectangle, what we're going to do next is we're going to revolve cut it. So similar to extruding, where you take your shape and drag it in one direction, revolving is taking your shape, spinning it about an axis. Except we're going to be removing material instead of adding material. So for our sketch, we're going to revolve, click remove, and we want to revolve sketch 4, and we want to revolve it about this construction line that we made. And you see what it's going to do? It's going to hollow that part out a little more. It's going to look like. So now we have a cylinder with another bigger cylinder. Just have a bigger hollowed out space. And now what we're going to do is we are going to add more to that, or actually we're going to start working on the base of this part, the part that it rotates on. So on the same plane, we're still on the front plane, so it helps to keep that visible just for reference. We're going to start a new sketch. I'm going to open it up so you can see what it looks like. And this time we're sort of just making a Tetris block. We're just making an L. So from the origin, we just make a line out, go that way, and like that. Now, in the real world, when you're using either additive or subtractive manufacturing, if you're using a 3D printer or a lathe or any kind of machine, you want to know the importance of tolerancing. We could, here's the gray lines, like the light gray lines of the previous sketch. That's the cavity we made. And it helps to show how much of a space we have. These dark gray lines are our sketch that we have right now. And, I left a little bit of a gap because I don't want it to be fully pressed up against the sides of those walls. It could lead to friction. The 3D printers, 3D printers in general, they're not perfect. They could be off by just a little much. And if it's too big, then our piece is not going to fit. It's not going to work. It's not going to spin. So that's why we need to introduce tolerancing. That's why we left a little bit of a gap. And it's good to show, those hidden lines because it shows you how much space you have. So we have 0.175 for this length, 0.375, my bad, and 0.15, just this little rectangle thing. Oh, I'm sorry. And then 0.425 for this line. I had that hidden, my bad. Once we have that drawn out, now we're going to revolve this. So, I'm going to create a revolve feature. You want to revolve the sketch you just made, and you want it to be revolving about that center line again. And once you do that, it should generate something that is a different color than your main piece. And that's because Onshape, it's only going to do this in Onshape, by the way. In Onshape, it recognizes it as a second part. So because it's technically not touching it, it's its own thing. If you were to do this in Solidworks, it still is all kind of that one homogeneous shape. You could, well, that's not good. You could, paint it to be a different color if you want to, but that's not necessary because we are going to be 3D printing it anyway, so that depends on whatever filament we're using. So going back to this, it's a different shape. That's good. That means it's free floating right now. It's just kind of floating in space because it's not touching this. So we want to add to that. We want to add more to the base. So I'm just trying to rotate around. So we want to add that base, but we don't want to make it just yet because right now this circle and this base are at the same sort of Z height. They're at the same height. They're touching right now. So we want to add, another little gap. We don't want those to be touching. So we're actually going to, we're going to select this circle and start a sketch on it. We're going to make a new sketch just to add a little bit of tolerance in. This sketch is going to be the exact same circle. It's very simple. So that sketch should be 0.35 diameter. It's just going to be a little circle. We just want to add a little bit of a gap between the swivel, which is the base, and the pencil holder. And once you do that, you want to extrude it just a tiny amount just to add a little bit of a gap. I extruded it 0.02. That should be sufficient for the 3D printers. Just making a little circle and just adding a tiny bit of length on the bottom. So if I look at the back of it now, you can see now it's sticking out of it a little bit. That's exactly what we want. We just want a little bit of a gap. And now it's time to make the actual base. So if you want, you can click on that bottom circle again and make a new sketch. And this time we're making a much bigger circle. That's going to be the base. And this circle is, oh, why is it blue? There we go. This circle is 2 inches in diameter. So starting from the origin, just drag out with the circle tool, make a circle, make it 2 inches. I'm going to just hide these planes because I don't need to see them right now. So sketching from this cylinder, because we want that little bit of a gap, making a 2-inch circle, and we are extruding that. Oh, give it a second, just to load. And we are extruding that 0.2 inches. So now we have our base. So we're starting to get there. It's starting to look like our piece, but we want it to hold, pencils. We need to have a hole in the middle. So now we need to start cutting out a section. We need to hollow part of it out. And there's multiple ways to do this. The way I did it is by using something called a sweep. So we'll get to that in a second, but first you want to set it up, kind of like how we had to set up our loft feature. We have to set up a couple things for our sweep. Sweeping is kind of like extruding, except it's not in, it's in a user-defined direction. So however, whatever direction I want the sweep to go in, it will do that. So it's not necessarily going to be a straight line or, a perpendicular direction is what I'm trying to say. So first we want to set it up where we want to start this. So we want, the depth of this to go down a little bit above this cavity we made. We don't want them to be intersecting. We don't want the pencils to be able to fall through the hole. So I actually started a new sketch plane. And how I did that is kind of like how we made plane 1. So I took the top plane, and, in case you forgot, you go up here, click the drop down, click plane, and you want it to offset from the top plane 0.55 inches. I originally had it as 0.5 inches. I didn't think that was enough of a gap between, the bottom of the hole and the cavity, so I just extended it a little bit. If you want to make it, 0.6, feel free. It's not going to make too much of a difference. I think 0.55 is plenty of space, because if we zoom in, you can see where the plane is and where that top of the cavity is. Kind of hard to see because it's blue on blue, but there we go. So that's about how much of a gap we're dealing with. So we make that plane 3, and then we want to make a sketch on it. Now, because we're literally sketching inside the part, it's a little hard to see. I would recommend, looking at it from the top and just opening up the sketch on plane 3. And, don't worry about all these lines going on in case it's too much going on. You can click over here. Here, hold on, I gotta move the window again. Click over here and just click shaded just to hide all that. Don't worry about the rest of the stuff that's going on. Right now, we just want to make another circle sketch. So all you need to focus on is opening up a sketch on plane 3 and making another circle. This circle is going to be 0.79 inches. That's going to be the diameter of what holds our pencils. If you want to make it a little bigger, feel free. I wouldn't recommend making it smaller because it's already kind of small. This pencil holder, it's already kind of small. You can only hold like 3, maybe 4 pencils. So if you want to make it a little bigger, you can, not by too much, I wouldn't say. But 0.79 is a good baseline. That's on plane 3, so that's inside the part. It is 0.55 inches above the top plane. And then once you have that, now we want to actually make a second sketch. Now this sketch is going to be on the front plane. So you see how the front plane is just perfectly intersecting. Actually, maybe I made it on the right plane. You can make it on the front plane or you can make it on the right plane. Both of them are going to do the same thing because if I zoom out, you will see that both of them are intersecting through the part and they're both upright. So whichever one you want to use, I used the right plane, but you could also probably use the top plane, or I'm sorry, the front plane. But I did it on the right plane if you want to, copy exactly what I'm doing. And I just made a sketch on the right plane. So I just drew a line, from that circle I made. There's the plane and there's the circle of the sketch I just made. I just started a line and just drew it out. I just, extended it out. I made it 4 inches. That's not necessarily important. I just wanted this point to be above the rest of my part. I just wanted this to extend out further. So this just has to be long enough. You don't even need to fully define this if you don't want to. You could if you want to. I just wanted this point to be, high above the rest of my part. And I made this line, parallel. If I'm looking at this from the right, you can see, there's my right plane. I made this parallel to this line. Again, you don't really have to constrain or fully constrain this line. You just want it to be, sort of in this position. Because we are going to use the sweep command to take this circle and extrude cut it along this line, this path. That's what I was talking about before, how it's a user-defined path that we're cutting along, or extruding along. Right now we're cutting along this line. So you're going to take that sketch, and you are going to do a sweep. That sweep is this tube thing right up here. It looks the same thing in Solidworks. If you're following along in that, when you're making a sweep, you want to define what you are sweeping, which is that circle we made on the bottom, and the path of the sweep, which is that line sticking right up out of our part. And you want to make sure you're removing material. And once you do that, you should have something like this. Yeah, my hole, it's a little bit off-centered, but that's okay. It should be fine. If you want to go back into the sketch, I'm gonna delete this parallel mate for right now, so it turned blue, so I can move it around a little bit. And I'm just gonna move it back a little bit, click the check mark, and it'll update. Now it looks like that. So however you want to do it, really up to you. I'm gonna keep it like that. All right, we're almost done. Just a couple more steps. So after you do your sweep, so that's essentially it for your pencil holder, but now we want to customize it a little bit. This is entirely optional. If you want to just stop with this, feel free. Or if you want to customize it a little bit, then, keep tuning in. So now we want to sort of, if you want to, you can actually sketch and extrude out or cut extrude, your initials or something. That's sort of why I, made this hole off-centered, because I want a little bit of space up here. Oops, sorry, I thought my fire alarm was going off. I wanted a little bit of space up here for engraving something. So if I show sketch 10, I put the letters ASME here, but if you want to put your initials or you want to put anything else you want that's going to fit, you can do whatever you want. So when you open up a sketch, you have this text tool, you click again, and drag out and make the box. You can vary what size it is. And once you make your rectangle, you can type whatever it is that you want. So, I'm going to type test. You can change what font you want it to be. If it's bold, if it's, italic, you can flip it to be upside down or backwards for some reason. I don't know why you would want to do that, but you could. You have the option to. And there's my thing. And if it's too big, I can, resize it. Obviously, because it's all underdefined, it's all, just floating right now. So let's say I get it into a place I want it to be, or at least I get a corner in place of where I want it to be. I could click one of the corners, go up here, and I can fix it. So I just fixed that corner, so now I can resize it. And it's not floating away. Oh, see, it automatically defined that mate for me. That's why I don't really like Onshape that much. That's why I like Solidworks better. So I deleted that fixed mate, now it's free floating. Whatever you want to type there, feel free. As long as it's nothing too, like, offensive or anything, we can't have that. But I'm sure you know that you're all adults, I would hope. But yeah, I just put ASME, whatever works. You take your sketch, and now we want to extrude cut it away a little bit. And we want to cut away enough material that it shows up in the 3D printer. So you want to go to Extrude, remove material, and I believe, let me just check, but I believe I removed 0.1 inches away from my lettering. So that way, if we zoom in, the E is kind of cutting into my material a little bit. Oh yeah, actually, probably made it a little too big, but that's my fault. But if we look at it from the side, it is enough to sort of engrave into the part. Maybe, I'll make it 0.9 inches. Why is it doing that? Oh, 0.09, that's what I meant to do. That's looking better. And then, you can change this up, obviously. Now it says ASME. Now, just a couple other things that we want to maybe change to make this a little easier on the printer is we want to add fillets. Fillets are simply rounded corners, rounded edges. In general, when you're making a part, whether you're machining it out of metal or you're just 3D printing it, corners and fillets are better. Or I'm sorry, fillets and rounded edges are better than sharp corners because A, you're not going to cut yourself if you're running your hand along it, and B, rounded edges and fillets are stronger structurally. We're just putting pencils in this, so we're not trying to make it take a lot of force, but in general, you should practice using fillets. So we're just going to add a couple. I go down here. I want to actually show hidden lines again because I'm going to make it, underneath. So shaded with hidden edges. So there's my little part. There's the cavity. You can see the gap between the cavity and the bottom of the hole. And we want to just add fillets. So fillets right up here. And I selected 4 edges, and I made them 0.05 radius. Let me just show you which edges those are. Come on. Oh. These aren't necessary, by the way. Like I said before, it's just a pencil cup holder. It's not super important, but it's good practice. So I filleted this bottom ring, and then this inside ring, and this inside ring. And it gave me this product. So I have a fillet there, there. It's kind of harder to visualize. Here, actually, I have an idea. I'm going to do it like this instead. So there's my part. This is Solidworks, by the way, and just changing, but it's the exact same part. Now I'm doing a section view, and this is what my part looks like. So I have a fillet on that inside edge, and that inside edge, and that inside edge, and that inside edge. So there's just 4. If you wanted to add one, in that corner, feel free. The SolidWorks model has this extra, little section up here. Don't worry about that. That is what my fellow workshop member, or I'm sorry, workshop manager added in the part. It's not entirely necessary. So we didn't make that tonight. So, don't worry about that. But however you want to add fillets, you don't have to make them huge. I just did 0.05 radius just to break the corner. But otherwise, yeah, it's optional. So going back to our part. That's it for tonight, actually. So let me show you how to take this to the next step. So you have your part, or maybe you have my part, however you've been doing this, and we want to export it. So for the 3D printers, they work best with an STL file. I believe they take a couple other different file types, but STL is just easiest. So you want to go down to your part. It should say Part Studio 1 right here. I just renamed it. You want to right-click it, and you want to click Export. And your file name, you want to make it your first and last name. So I'm going to make mine, my first and last name. This is just going to help it, organize it easier for the next step of the workshop. So you have your file name. It should be your name, and you shouldn't have to change any of this. Keep it STL. All this stuff. Just keep it the same. You want to download it. Click OK, and it'll download your STL file. Now, what we're going to do with that is we are going to submit that. So I'm going to post this link in the chat right now. This is the Google Forms for tonight. You are just going to simply upload your STL file to this. So I'm going to post this in the chat right now. Let me just stop sharing. And put this in the chat. So you can take that link, go to the Google Forms, and you can upload your STL file, put your name and a couple other little tidbits of information. And that will be all for tonight.